To start tonight with the focus on success. As I've been out and about in the community and participated in some debates and some chance to work with groups, I know there's confusion around the academic standards in math. And tonight we really want to show the progression in mathematics from grades K to 12. I'm going to ask Lori Gibson to come forward. She's been working with our curriculum director, Ryan Townsend. Lori is a secondary staff developer, and she has with her a team of math educators from kindergarten through secondary. Correct, Lori? So
yes.
Welcome, and thank you.
Thank you. Good evening, President DeLorme and board members. When my 22-year-old son was in 5th grade, he was asked to do a problem that looks something like this. And if we could get, which is larger, 3/4 or 7/10? He wasn't only asked to do that problem, but he was asked to work with a partner and show 5 different ways to prove one fraction is larger than another one. Now, as an adult, I'm thinking, how in the world would I do something like that? Well, when I got into some 5th grade classrooms, because I was really curious, what does this look like? And this was one of the posters that they created, 3/4 is greater than 7/10, and they actually showed more than 5 different ways to do this. To some of us, this might look like what they call the new math. And sometimes they say it's new math because of the different ways that students are trying to solve problems and trying to justify their answers. But as we know, Bismarck Public Schools, I mean, my 22-year-old was in 5th grade at the time. So for many years, we have been trying to encourage students to justify their answers, to make connections so that they will remember content for the long run. So, like I said, and it's interesting because Tyson, my 22-year-old, I can ask him what is 5/8 as a percentage, as a fraction. He will just spit it out because he remembers what he did in 5th grade for those 6 weeks. So we want so much more for our students than just memorizing the basic facts. Memorizing basic facts is so important, we all know that, but there's so much more we want from them. We want them to understand how math is used in the real world. We want them to be able to justify answers, problem solve, persevere, and most of all, feel mathematically empowered. So as we go through elementary, Sarah Jordan will take us through elementary, and they will show us how connections are made in the algebra strand from kindergarten all the way through secondary. So if we could have Sarah Jordan come up, that'd be great.
Algebra, we are going to be talking about today and look through the progression. It has its historical roots in the study of general methods for solving equations. Many of us adults remember school algebra as solving those complicated equations and simplifying expressions. However, algebra begins in the primary grades, in which students build a solid foundation of understanding patterns, those relationships among numbers, and the functions. Students begin developing an algebraic perspective many years before they will actually use those formal algebraic symbols and methods. As the slide shows, early experience with classifying and ordering objects are natural and interesting for kids. Teachers help their students notice these patterns and that they can be extended with another sequence and help them to predict upcoming parts of the pattern. Initially, students describe the patterns verbally and rather than just with mathematical symbols. They then progress towards writing their patterns down and sharing their thinking with others. In grades 3 through 5, students begin to use variables and algebraic expressions as they describe and extend those patterns. Students begin formal algebraic language by using a letter for the unknown quantity in an expression or an equation for 1- and 2-step problems. For example, up on this screen, through this word problem here, we now know that there is a missing variable in there, and students are taught that that's what they are looking for. That's the missing variable that they are looking for. They then begin to understand that the equal sign as a symbol of equivalence and balance when adding or subtracting or multiplying and dividing. As preparation for the middle schools, students up through grade 5 begin working more formally with expressions. Students develop a notion of a variable as a placeholder for a specific number. Later, they will learn that variables have a different use in much more complex equations. And when it comes to the more complex, I'm going to pass it over to Jeannie Metzger, who is in the middle school. She's a math teacher.
So now our children are in middle school, and we know that middle school is the bridge between elementary and high school. So whereas in elementary we saw lots of pictures of manipulatives and kids using things and then using them and then learning the symbols that go with them, in middle school we want to move them now towards the abstract. We're still going to touch on concrete when we introduce something, but we want to quickly move them towards the abstract. I'm going to skip a couple slides here. You can see they're starting to do more paperwork. And then when we get to middle school, it becomes all about relationships. And then we look at a problem with area, which is a common problem in middle school, and we start asking ourselves, if x is our length, when we change x, what happens to the area of the rectangle? And if we increase the x, does the area increase or does it decrease? And in order to show our work, we start to use mapping diagrams, which some people call input-output tables. And you can see that we have different inputs. If we put this number in for x, what is our output or our area? And from there we move to an x and a y, where we have two variables. And the sophistication and complexity of our work becomes very apparent in middle school. And we start to do things that use a lot more critical thinking, where kids actually have to write an equation. We want to keep it real, because at the middle school level, if the kids can't see why they're doing it, they tune out, and we want to keep them engaged. So if we look up here, we have a gift card, and we know that middle schoolers love gift cards. If you have a gift card for $45 for an online music store and each song costs 90 cents, how do we figure out how many songs we can buy with our gift card? Every middle schooler is instantly engaged. They want to know, okay, how do I figure that out? And so from there, we use that introduction to teach them how to write equations, using variables, using a constant. Do we have a coefficient here? And they learn all those vocabulary, and eventually they do learn, oh, I can write this equation, then I can put in a number into that variable, and I can solve my problem. And I hope this is a little more clear for you guys on your screen than it is on mine. It's a little bit blurry. Another thing we want to do in middle school is we want to move beyond formulas. When we were in middle school, many, many years ago, the emphasis was all about algorithms. It's all about formulas. If you memorized a formula, then on your math homework, if you could do the first one using that formula, you could do the 20th one too, because you used the same exact procedure. There was no variation. There was no having to apply your knowledge in a different way. It was just rote memorization and algorithms. With the Common Core, we want that progression to also include doing real-world problems where the situation might be a little different than the last problem. And so we really have to think critically. What do I need to do a little bit differently? What is my situation? Which operation will I use? And so, for example, up here we have a track. And the situation, in case you can't read that, is that in a 100-meter race, you give your friend a head start. Your speeds are shown. So show us what is a function that you could write to show your speed after n number of seconds. So after 2 seconds, how far would you be after 5 seconds? And then write a function that represents your friend's distance, because your friend is right beside you. So we're learning to write functions here. And then, now graph it. What would that graph look like? So now we're getting into taking different variables and we're graphing them along with our results. And finally, what does the intersection of the graph mean? And here's the real-world implication. What does that mean when the two lines on the graph intersect? And of course, the kids, by going through this, just realize that's when you pass up your friend. That's when you catch up and pass them. Every single day in middle school, someone asks me, why do I have to learn this, Mrs. Metzger? Because middle schoolers are famous for questioning. Why do I have to do this? And I always tell them, if you come across a problem that I can't give you in 24 hours notice why you're supposed to do it, you don't have to do it. And so we need to make sure that our problems are real. We need to make sure they're relevant to the real world and that they keep the kids engaged. And now I'm going to turn over the microphone to Sarah Kincaid from BHS, and she's going to talk to you about high school algebra.
Thank you. As you heard in the earlier grades, students are learning about patterns, input-output tables, linear functions. So then when they come to us at the high school level, when students enter Algebra 1 and then they progress through pre-calculus, they use what they already know about functions to describe relationships, but then they discover that not all patterns are linear, so not everything can be represented using a line. We work with quadratic functions, exponential functions, trig functions, and trigonometric functions are interesting. This is one example of some student work that kids are doing in an Algebra 2 class to explore what a trig function looks like, or the sine and cosine waves. So we're exploring those key characteristics of even the complicated graphs when they expand beyond linear. During our work with these new types of functions, kids dig deeper and analyze them. So they're generalizing the function's characteristics, their features, their graph. And one example of students being asked to generalize is posed by this question: if we change a value in an equation, what effect will that have on a graph? So what role does that key number play in that equation there, and what effect will that have on the picture? And students can graph the changes, they see the results, they generalize those results, and we do all of this with the end in mind. They're going to later use these generalizations to move them to a successful way of using these things to model. So basically, like Jeannie was saying, in real life, that's what it's all about. So this is an example of one activity that we do in our Algebra 2 classes as well. They're going to build functions to model a set of data or to fit something in real life. So these are the water fountains that we have at Bismarck High School. Students use their knowledge of shifting the graph and flipping it over to calculate the equation of the water leaving the fountain. So they've been literally drinking from a parabola all this time and never really put much thought into it. So it's been pretty awesome. We're really excited about the connections that students are making at all grade levels. Connections between math concepts, connections to things in real life, connections that are no doubt going to make them better problem solvers, critical thinkers, communicators. We want to thank you for allowing us to come tonight and share with you these exciting opportunities that we have. Thank you. Have a good evening.
Thank you.
Thank you.